So this is number 3, the question about the coin and square spinner. In the first part of the question, part A, asks about the probability of obtaining a head and consonant. So you know that the probability of getting a head is 1/2, and the probability of getting a consonant is 3/4. Therefore, you multiply them to get the answer 3/8. You do the same thing in part B when it's asking for a tail and C, where you multiply the probability of getting a tail and getting a C, and that gives you 1/2. And for these problems, which are AND problems, in probability, an outcome is an event A and B only when the outcome is in both event A and event B. So you have to be sure what type of operations you use when it says and then when it says or, which is like the next problem, where it says a tail or a vowel or both. So in this problem, you have to go through the equation of, you have to add the probability of A occurring, add the probability of B occurring, and then subtract it from the probability of both occurring, which is exactly what this part C indicates. So there you get the probability of getting event A, which is a tail, and that's 1/2, then the probability of getting a vowel, which is B, which is 1/4, and then subtract it from the probability of both occurring at the same time, which is 1/8. And this equals, you have to get a common denominator, and this would equal 4/8 plus 2/8 minus 1/8, which gives you the answer 5/8.
So this is for the fourth problem, and the fourth problem states that the probability that a man will be alive in 25 years is 3/5, and the probability that his wife will be alive is 2/3. So for A, you're supposed to determine the probability that in 25 years both will be alive, and this is an AND issue, so it's you use multiplication, so you multiply the probability that the man will still be alive, which is 3/5, and the probability that his wife will still be alive, which is 2/3. That gives you 6/15, which can be reduced to 2/5. For B, you're supposed to find the probability that at least one will be alive. So this is an OR problem, and this can be done by adding the probabilities that adding the probabilities that they will both be alive. You have to find a common denominator, which is 15, and that gives you 19/15. But then you also have to subtract the what we did in A, that both will be alive. So you need to subtract 6/15 from that. So 19/15 minus 6/15 gives you your final answer of 13/15. And then for C, you need to find the probability that only the wife will be alive. And this can be done by multiplying the probability that the wife will be alive, which is 2/3, times the probability that the husband will not be alive, which is 2/5, because 2/5 plus 3/5 is 5/5. And this gives you your final answer of 4/15.
So for this problem, it states that there are 22 students that take econ, 25 students that take law, and 3 that take neither out of 40 students. So for this, first I had to find out how many took both, so I could complete my Venn diagram. And for this, I set up the equation 22 plus 25 plus 3 minus x equals 40. And I got x equals 10, that 10 students study both subjects. So as you can see, I subtracted this from both sides of the Venn diagram from the econ and law, and got 12 students studied econ separately, 15 studied law, and 10 studied both. So for A, both law and economics, the probability is 1/4. At least one subject studied, the probability is 37/40. And the probability that they study economics, given that they study law, is 10/25. Okay, so this is number 5. So it says the probability of y equals 0.35, and the probability of x union y is 0.8, and that these two variables are mutually exclusive. So when it asks probability of x or y, or x and y, it's going to be 0, because these events are mutually exclusive and they will never happen at the same time. And then for B, it asks the probability of x is going to be 0.45, because the probability of x or y is 0.8 and the probability of y is 0.35. So I subtracted 0.8 from 0.35 and got 0.45. And then for the probability of x or y, it is given in the problem, so it is 0.8.
Two independent events, A and B, are independent if the fact that A occurs does not affect the probability of B occurring. Mutually exclusive events. These events cannot happen at the same time. Now we'll play an event game. Is turning left and right mutually exclusive or independent? If you said mutually exclusive, you're correct.
You didn't give him any time.
It raining and eating ice cream. If you said they were independent, you were correct. Falling asleep and watching TV. If you said independent, you were wrong. It's mutually exclusive.
Alright, so this is for problem 7. The first thing I asked you to do is to graph. First thing I asked you to do is to graph the sample space of all the possible outcomes for rolling 2 dice, and that looks like this. It's basically just showing all the results that the 2 dice can have. And the first question is determine the probability of getting a sum of 7 or 11, and that's done just by looking at the sample space graph and then just tallying up all the results that would get you 7 or 11, such as 6 and 1 or 5 and 2. And there are 8 of those, so the probability is 8 over 36, so there are 36 possible options, which can be reduced to 2/9. And B is the same process. It asks for a sum of at least 8, so you just count up all the ones, the combinations of die that would give you a sum of greater than 8, and that is 15 over 36 or 5/12.